Up next, we have Andriy Redko, staff software developer at Aiven, who is going to be talking to you about how obtaining fast query times when dealing with large amounts of data in OpenSearch can be a challenge and how there isn't one single solution that works for all use cases. But he'll explore two orthogonal but closely related techniques that can help you overcome these challenges that became available to the community with the launch of OpenSearch 2.1.0. Please welcome Andriy.
Hello, folks. I would like to apologize beforehand for fairly technical talk, but I will promise to try my best to not go into Apache Lucene implementation details and just outline enough for everyone to understand what is going on. So let's get started. Improving search query times in OpenSearch could be very, very challenging. And unfortunately, when you deal specifically with a large amount of data, there is no one single solution which works in all cases. In this talk, we are going to talk about two slightly orthogonal but very related concepts to address the problem at hand. One is merges at refresh, and second one is usage of multiple threads, at a search phase. Each of these techniques has certain trade-offs in terms of CPU utilization and I/O operations. And in the benchmark sections, which we'll see later on in this talk, we're going to see how each of this strategy plays off. And just a few words about me. So I'm a software developer working at a company called Aiven OE. That's a Finnish company. I'm very grateful for trust to become an OpenSearch committer. Really proud to be part of the team. My personal details, please feel free to reach out on any of these channels. We'll be happy to chat with you. I don't have Twitter. That's a good one. And as you can see, I'm in shorts. I'm from Canada. So plus 40 Fahrenheit is still summer in Canada. So we're enjoying that. So let's get started. Apache Lucene. Nick already talked about Apache Lucene today. It's one of the oldest search libraries out there. It's been 23 years old, but despite its age, it's still innovating and improving a lot. OpenSearch relies on Apache Lucene for mostly everything, and bringing new features and new improvements to OpenSearch is what we try to do all the time. As we're going to see, some of these features are easy, some of them require a significant amount of changes, and not easy to improve in the core. Let us start with 1000 feet refresher on how OpenSearch stores indices. So as all of you know, OpenSearch is a distributed system. It's usually deployed as cluster of nodes. On each cluster, you have different types of nodes, and OpenSearch tries to split indices across smaller chunks called shards and distribute them across data nodes. What is shard? Essentially, under the hood, the shard is a small Apache Lucene index. And this is basically what we deal with on OpenSearch. Each single Apache Lucene index consists of segments. You already know about segments from Nick's talk. It's just basically a set of different types of files. So how those segments are basically managed by OpenSearch? So every index consists of a set of segments, and these segments contain only the subset of indexed documents. When new documents are ingested into index, they not become available for readers right away. Only when index writer commits, these new documents become available for search. As you can imagine, when segments are persisted, they are already immutable. They never modified in place. And the problem is obvious. The number of segments is growing over time. To maintain search efficiency, the chunks of the small number of segments have to be merged into a larger one. Otherwise, your search will be slower and slower and slower. This is usually done on a schedule or using force merges. However, this operation is pretty intense from I/O perspective, and usually has to be done when clusters are idle. In OpenSearch, we don't operate by flushes and commits. We better know this functionality as a refresh, which basically is configured through refresh intervals. So we know what is index segments and how they operated at index time. So let us take a look what is happening when segments at search time. When search query comes in, the coordinating node distributes it across data nodes in a cluster, and in particular, it runs down to a distribution across relevant index shards. On each shard level, respectively, each segment is consulted sequentially for documents with match search query. There is only one single thread which goes over one segment at a time and collect documents. So in this context, it becomes very, very clear what it means to have growing number of segments. The search becomes slower, slower, and slower. What can we do about it? So the first thought which comes to mind is to reduce somehow the number of segments. We already know about force merges, which are pretty heavy. But in the recent releases, Apache Lucene has introduced a very new feature into Index Writer called merge on a refresh, which aims to reduce amount of small segments while you're indexing. Still, since this operation can still take some time, it is capped to some configurable value. If merge exceeds this configurable time bounds, the merge won't happen. Everything will proceed as before. Additionally to that, Apache Lucene introduced a new merge policy called merge on flush. This one works a little bit differently and takes place at a flush phase. The decision what to merge is based on on segment threshold. Both these features aim at a single goal: to reduce amount of segments at a lower cost. Let us look at benchmarking. The benchmark I've done using OpenSearch own benchmarking tool called OpenSearch Benchmarks on one of the workloads we have in a repository. The force merge task were intentionally turned off, so the force merge won't happen at all. The baseline is OpenSearch 2.2, just bare distribution without any configuration tricks. And the container has only two properties configured. One is merge on flush policy, and the second one is slightly larger merge word times, so we can merge more segments as you go. The report has tons of metrics, so I just filtered out not the ones which are not interested to our experiment and highlighted only the important ones. The first thing which catches the eye is number of segments. It's 3 times less. Also, if you look on search percentiles, they are slightly better across all set of search queries. On the downside, you can see that the time spent on merges is as twice as it was before. With such kind of configuration, it's expectable. This is trade-off we have. Merges on refresh and merges on flush do have their limits. At some point, you will still face the problem that larger segments has to be merged. And this is basically returns to square one. But what if we tackle the problem from the other end and we don't care about segments, but instead of traversing them sequentially, we'll go concurrently over all of them. Interestingly, Apache Lucene has concurrent segment traversal feature available for last 4 years. But to bring it to OpenSearch, non-trivial implementation changes in core would have been required. The way it works is basically by injecting thread pool in index searcher, which distributes the search task across every single thread in a pool. The results are consolidated at the end. It highly reminds a scattered gatherer or MapReduce approach, and actually it is approach like that. So the benefits of using concurrent segment traversal were so obvious that community issue has been created in OpenSearch core to bring it in. And with that, the new plugin was born. We released the concurrent sandbox, concurrent plugin, concurrent search plugin under sandbox umbrella. The way it works is very, very simple. It just injects when plugin is installed, it just injects the thread pool into index searcher path, which automatically triggers concurrent segment traversal on the Apache Lucene side. As you may guess, if your index contains just one segment, the concurrent segment traversal won't trigger. Apache Lucene is smart enough to understand that. Unfortunately, as of this moment, the sandbox plugin are not part of distribution and not published anywhere. We're working on that, but luckily it is very easy to build your own plugin for Apache or for OpenSearch release you've been using in production. The few steps are right here, and sorry for slides, I a little bit mess up here. But to understand if concurrent search path is being picked up or not, the simplest way is to turn on debug logging. If you have debug logs available, you will see concurrent query phrase concurrent query phrase searcher popping up in your logs with concurrent search over segments message. But certainly for some environments, modifying the logging settings for entire cluster is not possible. So there is a better way. You can use the search query profiles. The search query profiles are triggered when you specify profile property in search queries. The information is returned related to query, but the change which we are curious to see is in collector section. On the left, you can see the old one, which is basically, we can call it sequential traversal. You will see collector in name. But on the right, which is concurrent segment traversal, you will see collector managers. This is primarily difference. The query section doesn't change at all. So let's get to benchmarks and see how concurrent search plugin behaves. Again, I've done the OpenSearch benchmark tool on sample workloads. Force mergers are off, so we keep as many segments. You can see the numbers are pretty high. It's in contender and Benzlite, it's all the same. The results are not as good one as with merge policies. There are certain improvements for phrase and scroll queries, which are highlighted here. However, for other types of queries, the results are not so impressive. They are mostly the same numbers, which basically means, does it work at all? Why should not improve all queries? Yes, it works. In general, it works very well. I just highlighted the threads trace from a GMC console, so we can see the thread pool is pretty busy. And in general, it improves search times. But there are several caveats with that. First is that if index mixes large and small segments, the large segments can still dominate the search times. Unfortunately, as of now, Apache Lucene does not parallelize or does not concurrently search within the single segment. It's only by segments. So in mixed indexes, you may still have an issue that all large segments are taking all the time. Also, when clusters are under high search load, specifically with search queries, you may run into issues that search queries start to compete for a thread pool and start to queue up instead of making progress. This is also one of the areas of improvements where we are working on right now, but it's not solved yet. With that being said, please take these benchmarks we've seen before with some grains of salt. There is an effort, and very close to be released soon, to have a continuous benchmarking infrastructure for OpenSearch project. So we can have numbers published on a regular basis across different release and development branches. Highly encourage you to run benchmarks yourself on your sample workloads and help us to improve plugins and merge policies by sharing the findings and results. There are some limitations with the current plugin, which all are the points for future improvements and future work. Early termination is a pretty cool feature when you can terminate the search query by some condition. For example, you just want to have 10 results, and that's it. Super easy to do when search is sequential. You just follow the search, and then condition is met, you stop. But when multiple threads are involved, it's very difficult to coordinate them. Obviously, you can introduce synchronization primitives, but then you become point of contention. And basically, we'll erase all the gains you have right now with concurrent processing of segments. So we're looking for a solution in this area. Returning partial results is a very useful feature when query times out, for example. When query times out, you can return whatever is collected so far in sequential flow. However, the same problem happens with when multiple threads are crunching over segments. You just return nothing at this moment of time. The good news is that in recent release, maybe a couple of months ago, Apache Lucene had introduced a new feature to natively support timeouts in index searcher. This is already brought as an issue to OpenSearch for reference here, and hopefully we will pick it up very, very soon, integrated natively. So this problem will go away naturally. Aggregations right now are working as part of the search processing of the sequential flow, and they build along as you traverse segments. This part is not yet migrated to concurrent search because of significant efforts required at the moment. So right now, when search query includes aggregations in the payload, they automatically fallbacks to sequential flow happens. Also, as of now, there is only one thread pool which is shared on data node between all indices and all shards. This may significantly hurt the fairness, and we are working to provide more selective and more granular configuration so you can turn it off or on for specific indices or shards. And last but not least, publishing sandbox plugin is something we've been discussing for a long time, and hopefully we will have it somewhere either in distribution or on publicly available URLs somewhere to be used, and you don't need to build them by hand. Merges on refresh and merges of flash can greatly improve the search performance of your indices, for your indices. Add to that the concurrent search plugin, which despite its limitation is still very useful and can significantly and remarkably improve the performance of your search queries by keeping all cores busy. Please give it a try these features, give them the right on your production workloads, and just share your findings with us. We will be very, very curious to know how it's helpful it is for you and where we have the gaps so we can work and address them. With that, I'm leaving you a couple of links for concurrent search sandbox plugin and merge on refresh documentation page. And thank you very much for attention.